Hello guys, welcome to another video from Code Jam. Okay, so this video follows our previous video on where we did a quick review of the ESP32 development module or development board from Laligo. Okay, so we talked about the different pinouts, we talked about the some features of the board, the number of processors, the kind of processors, and all that. So in this video, specifically, I'll be walking you through how you could connect this board to AWS. Okay, so the idea is we want to program this board, which is the development board from Laligo. We want to program this board to be able to communicate with AWS securely. Okay, so it's not just sending or connecting to any HTTP endpoint, but this time we're securely talking to AWS IoT Core. Okay, so the idea is once we get this done, this board should be able to send and receive data from AWS through MQTT protocol. Okay, so let's jump right in. First of all, you have to log into your AWS account. So we're going to just break down the process in two. The first step is setting up and creating the necessary resources on AWS to handle the device connection. Okay, so and then the second part is where we get to use those like the connection, the certificates that was generated on AWS, and then we're going to program the microcontroller here to connect to AWS. Okay, so let's do the first part, which is creating the necessary resources on AWS to allow the device connect. Okay, so the service we'll be using is AWS IoT Core. So if you've opened it before, you'll see it right on your dashboard here. If you've not, then you could just type IoT, and you would see AWS IoT Core here, IoT Core. So just open it up, and yeah, so we've now opened up AWS IoT Core. So the first thing we need to do here is to create a thing, right? So because the way we think of it is there are several devices you could be connecting. So each device is like a thing in AWS, right? So it's like a thing sending data to AWS IoT Core. So the first thing we want to do first, create a thing. So under the all devices, we'll see things. So we want to click on create things. Okay, so we'll just be creating a single thing because we've got only a single board here. But if you have multiple board, you want to configure all of them at once, then you could do multiple. But for now, we're just creating a single thing. Okay, so we'll then click next, and then we need to give our thing a name. So I'll choose a name which is ESP32 So this is like the first ESP we're configuring. Okay, and then the thing type. Now this field is populated when you actually have previously created a thing type. So I have previously created a thing type called board. So if you've not, you want to create a thing type, but this is optional, right? It's just for you to like see what thing you have, what category of, or the way, depending on the way you categorize the things, but it's optional anyways. Okay, so we've just added a name and then selected a board, and then next we click next, and then we get to the certificate part if we want to use an existing certificate or automatically generate a new certificate. Okay, so for this demo, we're just going to automatically generate a new certificate. We'll just click next, and then now we need to attach a policy. We need to either create a policy or attach an existing policy, right? So policies are the way permissions are handled in AWS. So policy says what resources can connect, if a resource can publish to a particular topic and all that when it comes to AWS IoT Core. Okay, so since we don't have any existing policy, we just have to click on create policy, and we'll give a policy name. We'll call it ESP1. ESP1 access or something like that. ESP1 push data, or we'll just say ESP1. That works. Okay, so next we need to like define what permission we're giving to this board. So the way I like it is I already have a JSON file, so I could just toggle to use the JSON builder, and to just be quick, I'll paste in the JSON document here. So I have a JSON document opened up here, so I'll just paste it in and explain what the permission given. So what this is doing is, this is how AWS, you define permissions in AWS using JSON. So this is the effect, that is, this is align the following action, which is push, receive, and publish, retain. So this is all relating to AWS. You can see the resource name here and all that, and the action. Okay, so what the first one is doing is allowing allowing anything to push to the ESP32 topic. All right, so you're pushing to a topic name ESP32 slash anything. So it could be anything like slash pub slash sub. Okay, so this is allowing access to push to this topic. This is also allowing access to subscribe. So any device connected with the certificates where this policy is to be attached to has the permission to actually subscribe to the ESP32 topic. And also this policy allows devices to connect. Any clients can connect on IoT Core. Okay, so that's what I think, that's what this policy is doing. But policies could be more restrictive. You could add more things, but for what we want to do for this demo, this policy is functional, or this policy works. Okay, so next we just click on create, and you could see that this creates a policy for us, and we could go back here and would see that we have our new policy here. We just have to select that policy and then click on create thing. All right, so this would create the thing, and now we need to download the necessary certificates. So since I said when I started this video, I said we're going to be connecting securely, and that means we need some form of authentication. These devices need to authenticate that look, they're actually correct, or they're authentic. So now let's download the device certificate, which is the first thing. We just download it. That's downloaded, and then we need to download the public key. Download the public key. We also need to download the private key, and also we need to download the root certificate. Okay, so we'll just download it. I think those are what we need. There are multiple certificates, but for this demo we're just going to be making use of just the first root certificate. So I think that's it, and we just click on done. So with this setup, we have our new thing created, which is the ESP32 thing. And if we open it up, you see that we have the certificates, the new certificates attached to it. We also, if we click through the certificates, we see that we have the policy attached. So this policy allows the the device itself to access AWS and push or subscribe to a given topic, since we're making use of MQTT protocol. Okay, so that's it. So let's go over to the next phase where we get to use our certificates, that is the certificates we downloaded, and then we use that to program the board. We'll be using the Arduino IDE. So Arduino IDE, you can get Arduino IDE by just going online and searching Arduino IDE, and on here you can just go to the Arduino website. Arduino also they have their development board and all that. So we will be programming the ESP32 from Arduino with the Arduino IDE. So depending on your operating system, I'm on Mac, you could either choose to download for Linux or for Windows. Okay, so once you're done installing the Arduino IDE, the next thing to do is just to open up the IDE. Okay, so over here I have the IDE opened up. So for you to get to this screen, once you open up the IDE, then you click on file icon here, you just click on new sketch. All right, so and sometimes it just automatically open up a new sketch for you if you have none. Okay, so let's start. I would be sharing the code on GitHub. Just to follow along, you might just copy and paste the code. Yeah. So first thing, we want to add some files, create some files. So I will just save this first by hitting Ctrl S, Command S, and then giving it a name. Let's say ESP AWS, right? So we save this. Yeah, so giving it a name, ESP AWS. Next, we want to create some files, like separate our code into files, and I'll just create those files. I'll just click here, new tab. I'll name this sat So we'll store all our certificates on this file, sats.h header. That is like a header file or something. Okay, so next we want to add a new tab again. So we want to this time around we want utils, some utility functions. We want them inside this file. Okay, and then inside the sats.th we'll get to configure our Wi-Fi clients to connect to Wi-Fi. That is set up the Wi-Fi password and all that. Okay, so first of all, I'll just get so before you get to this stage, you want to make sure that you have the necessary libraries installed, and the libraries you need to ensure you have is the ESP. You need to ensure that you have the board ESP32 dev module installed in your IDE. That is, you have this, you can, if you look up here, you see ESP32 dev modules. So to do that, I think you can click on board and you can search for ESP32. Okay, and you see I have this ESP by Expressive installed. All right, so I think this comes with the board. So once you have this installed inside your IDE, then you'll be able to see ESP32 dev module. And also you want a library. We'll be working with a library, the Arduino JSON library and the PubSub client. Okay, so if you click down here inside libraries, you just search for Arduino JSON. Okay, so you see I have it already installed, the Arduino JSON library. You just click to install it. Okay, and also you want to install another library, which is the PubSub client. Okay, so if I scroll down, I'm looking for it, PubSub client. Okay, so you can see it here, the PubSub client by Nick. So you want to have that installed again. So this is what creates the lightweight MQTT connection. Okay, so those are the libraries we'll be using for this demo, and we'll just first of all, we want to have our certificates in here and all. So I'm just going to be pasting the code. All right, so first of all, we're including a header file because we'll be having macros later on in the code. Then we want to define our thing name, which is the name we give to our thing on AWS. Okay, so if we look here on AWS, if we go to things, we'll give our thing a name which is ESP32_1. And I think that's still the same name. Okay, that's different. So ESP32_1, that's our thing name. Then we want to also define our Wi-Fi connection variables to hold our Wi-Fi connection credentials. So my Wi-Fi SSID, that's the name of your Wi-Fi network, is Viper, and the password is Snapdragon. Okay, and then we want to define our IoT endpoint. Okay, so our IoT endpoint, if you want to find your IoT endpoint, you just click on connect to one device and scroll all the way down and copy this URL here. So this URL, just the URL part here without the ping, is your IoT endpoint. Okay, so we'll just go over to our code and I'll paste my IoT endpoint. Okay, so just to confirm, you see that 833, and if you come here, 833 ends with amazon.com. I think it tallies with the region here, which is, US East 1. Okay, so let's go back to our things and let's keep updating the code. Okay, so real quick, first of all, we want to add the root certificate, and I'll just copy what I have here and then we'll paste this. So remember when we created the thing, we downloaded some files, which is like the permission file, the root certificates and all that. Okay, so I'm just going to go over and open up those files. Okay, so first I'll open up the root certificate and let's just go here. I have those files downloaded here. and I can just right click and open with or open this up with the text editor. So down here I'm looking for my text editor. I just select text edit and open up, and you see that we have the root certificate here. So we just copy that and we'll go over to the right here, and it's still the same thing because of course AWS would have the same root certificate itself. Okay, so I'll paste that, and next we want to get another certificate, which is the device certificate. All right, so we'll just scroll all the way down here. I'm just going to paste it. Call this device certificate. By the way, we're actually writing kind of Arduino C++ here. So device certificates, I'm just going to remove the existing one I have here and pasting the one we got from our device we created. Okay, so I'll close this, and this is the device certificate. If you look here, certificate of pen file. All right, so I'll open this with again my text editor. Text edit. Okay, so you could open it with any file editor or VS Code or whatever code editor you like. So I'm just going to copy this and paste this inside the code. Right, so inside there I'm going to paste it. I think we missed some parts, the beginning and end certificate. Yeah, so let's copy it properly. Ensure you include the beginning and end certificate portion. So paste that, and everything looks good. And then next we need the PEM files, the device PEM files. Okay, that is the private key file. All right, so device, paste it, and we'll replace it with the correct one. All right, so close this one. Now the PEM file, the private key file, right? So just right click and open with, and I'll open this up with text, my text edit here. All right, so I'll just copy this here with the begin RSA and declaration, and I'll paste this. Okay, so we have all our certificates all set up. We have our Wi-Fi connection parameters. We have our IoT endpoint. Now the next thing is we need to create some utility functions to allow us make use of this parameter and connect to AWS. Okay, so over here to the other file here, we'll just open it up and we'll add some functions. Okay, so first of all, before we do that, we need to import some files. So we're importing the built-in Arduino library. We're importing the sats.header, which is the file we've been working on here. And then we're also including the Wi-Fi client secure. I think this already comes with recent Arduino IDEs. We're also including the PubSub clients we installed, Arduino JSON file, and also the Wi-Fi header files. Okay, so those are the header files we're using, the libraries we're including. Okay, so next we need to define some variables. We're using arch define here. This is all C++. Thinking we're defining a variable that holds the topic we'll be publishing to and the topic we'll be subscribing to. Okay, so if you remember, our permission allows us to subscribe or to publish to any topic with ESP32 right in front of it. Okay, so again here we're initializing the libraries. By the way, I'm going to make this code available, so just in case, just use the code directly. So we're initializing the Wi-Fi client and the PubSub client. And next, we want to define our message handlers. And all right, so it's a function for handling incoming messages. Just pasting that. Okay, so we've got our message handler. Next, we want to define a method that connects to AWS. Okay, so I'll just paste that. All right, so we have the method to connect to AWS. So what this is just doing is this message handler here is just receiving the topic and the payload to as well as length. So it just prints out the incoming message, and then just puts it in a JSON document, and the message comes as JSON, so it's realizing it and printing it out. Okay, so next, where the next method connects to AWS, makes use of the Wi-Fi connection, begins a Wi-Fi connection, prints out a message indicating if it's connecting to Wi-Fi, and keeps the connection. And if the connection is not successful, or while it's still connecting, it prints a dot with a 500 or 500 milliseconds delay. Okay, so here we're also initializing the certificates, setting up the AWS root certificates. We're setting up the device certificates, and we're setting up the private key files. And then we're also connecting to the server, connecting the client, which is the PubSub client. We're connecting it to the IoT endpoint here on port 883. Okay, so we're also setting the message handler, so that on the client, whenever there is a message, this function gets called. Right, we're printing out a statement once the connection is made, or once the connection starts. Okay, and the same thing here, while the connection is still on, we're printing out a dot here, and we're delaying for 100 milliseconds. Okay, so if during a given time interval the connection is not successful, we print out a timeout error message. Else, once the connection is successful, we would then subscribe to the topic, subscription topic, which is the ESP32 sub. Okay, so this means that our ESP32 board could push data to a given topic and could also receive data from a given topic. All right, so the last part, we're now printing to the console that AWS IoT Core was successfully connected. Okay, so this is it. This is all C++ thingy, and okay, so we include our last method here, which is the publish method, publish message method. So we'll copy this and we'll go inside our and paste it. So this piece of code, what it's doing is just receiving a message, which is some metrics value, and it's putting in a JSON document, it's creating a buffer, and then it's publishing this message to the published topic, which is what we define here. Okay, so it's just a function to publish message to the given MQTT topic. Okay, so over here now we go over to the main file, which is the Arduino file. Right, so this is the file that gets run once our board starts working or comes on. Right, so the setup method is what runs first. It's kind of, you can think of it like an initialization process for the board, and then the loop method is what keeps, or function is what keeps running over time as the board stays on. Okay, so first of all, we need to import some libraries to this file, and we would import the Arduino built-in library. We'll import the utils. The utils is just the file we just created right here. So we need to even rename this file to utils.h. Okay, so utils.h, which is this file here where we have all the methods we're using just to keep our code clean. We're also making use of the PubSub client. Okay, so next we need to call the methods we created earlier. So we're calling the connect to AWS, and this one will be with this code. The first line 6, will begin a serial communication at 115.200 baud rate, and then call the connect to AWS function. And you can see that the connect to AWS function is defined inside this utils.header file. And you can see that we have a connect to AWS function. Okay, and then next we need to now work on the loop function, which is what keeps running once the board initialization process is done. Okay, so first of all, we want to mimic some random values getting sent by the sensor. Getting sent maybe by a sensor from the board. All right, so we're just generating a random value from 1 to 10. All right, naming that metrics value. And we're just going to be printing out that value on the serial. All right, so we're just going to print out on the serial monitor, and then we're going to publish it as a message, right? So to AWS IoT Core. So here we're just calling publish message, which is a method or a function rather inside the header file. Okay, so here publish message. So it's just we need to pass the metrics value, and then it's to call clients.publish and publish this to the given topic here. Okay, so we have that going. We have a client.loop, which just keeps the client connection open and delay for 1 second. So this what this is doing is we're going to be publishing this message for every 1 second, right? Once every second we publish a message, every second we publish a message. Okay, so this is the code, right? From the ESP32 file, which is the main file. We have our certificates all linked up. We also have our header file where we define the different methods we're using. Okay, so I'll be providing this code at the end of this video, so just in case you want to just have the code and not worry about writing it yourself, but you could modify it and use it as you wish. Okay, so this is it. So the first thing we want to do now is to actually test that the code compiles, all right, correctly. And to do that, we just need to click on the verify button up here. So once you click that, it will take a couple of minutes or seconds, right, for this code to compile. Okay, so I'm having an error here, start.header. So we made a mistake with the name here. So inside utils, we're importing sat. So, and we named it with an A. So we just have to rename that to CERT. CERTS. Okay, so just check that and just verify CERTS, yes. So we hit compile again. Okay, so this will take like some minutes, so I'll just have to pause the video and come back. Okay, so as you can see here, it's done compiling. You can see that Sketch the output is not showing an error, right? So Sketch uses this number of bytes and all that. So next, what we need to do now is take this piece of code and upload it to the development board. Okay, so I've got the microcontroller here now. The next step is to, as I said, is to connect this and upload the piece of code we've written into it. Okay, so I have my USB connected to my computer, so I'll connect the other end of the USB to the microcontroller. And on connecting this, you should see a light blinking on it, showing that there is an active connection. Okay, so I've got the connection there. Now we need to upload the code. Okay, so you can see just can see that it's the lights are up. First thing we want to do is in your editor, that is your Arduino IDE, you want to make sure that you have the board selected here. So you want to make sure that you've selected. You could click on select other boards and ports to select it, but make sure that once you click on select other boards and ports, search for ESP32 and you would find the ESP32 dev module on this just on here. So if you scroll down, let's just find dev, search with dev. So right here you see we have the ESP32 dev module, and then you want to make sure you're selecting the serial USB serial. Okay, so we just select the USB serial and OK. And once you do that, you'll see that at the bottom here you have that you see that there's a connection through the USB serial connector. Okay, and then for us to upload into the board, we just click the upload button here. So it's the arrow pointing towards the right. Okay, so once we click on there, you'd see that the board is still showing the blue color, but it's gradually, first of all, it needs to compile the code and then before uploading into the board. Okay, so that's going to take some minutes, like a minute or two, to completely compile and upload. Okay, it's still compiling. Okay, so it's done compiling, and the next part now is uploading. Okay, now it's uploading to the board. You can see here uploading. Okay, so uploading gonna take like another minute or two to completely upload. 11%. Okay, so it's at 100% now, and it's done uploading. Okay, so once it's done uploading, we want to open up the serial monitor here. So this button here, the serial monitor, want to open that up, and want to click on the enable pin so that we can reset this, right? So once you click that, you see that all the things we printed out, you're seeing connecting to Wi-Fi and connecting to AWS IoT Core, and you can see AWS IoT Core connected. So this means our device has successfully connected to AWS IoT Core, and you see the metrics we're sending to AWS getting printed out, just as we did in the code here, where we are doing a metrics and we're printing the metrics value. Okay, so let's go over to the right and look into AWS to see what we have. Right, so open up things, and first of all, I want to look into the data coming in from this device, just for us to see that it's in real time. So I'll open up what they call MQTT test client, and I'll subscribe to I'll subscribe to the channel this board is publishing to. All right, to the topic this channel is publishing to. All right, so I'll just go over to our code here and go to the utils.header file, and I'll copy the ESP32/pub, and I'll put this here and I'll subscribe. Okay, and once I subscribe now, you'll see that we're getting the values being sent from this board inside AWS, and this opens us up to a lot of the ability to make use of this data in any way we want inside the cloud. We could save this in DynamoDB. We could connect this to anything. So this is what we want to do. Now our data is coming into the cloud. We have to make use of it and all that.
Yeah, so that's it. We've been able to connect this board, the dev board, to AWS. And if you are aware of the cloud like AWS, you know that once data gets there, you can do so much with it. Okay, so that brings us to the next video, where we're going to be like calling a Lambda function or saving records in DynamoDB tables of all the metrics sent by this board. I think it's amazing, and just hang on, subscribe to the channel, and keep the notification on. Thank you.